Solving quadratic equations by factoring part 2. Solve the equation by factoring. 14x squared plus 3x minus 2 equals 0. This equation is already written in the form ax squared plus bx plus c equals 0. So we can set up our two parentheses and set the equation equal to 0. Now we want to find the binomials that will go in each parenthesis. And when we multiply the parentheses together, we should get this original quadratic equation. Now, if you'll notice, this equation has a 14 next to the x squared term. This means that we'll do an added step than what we did in the previous problem. So the first thing is we'll look at the number in front of the x squared term, which is 14, and we'll list the factors of 14. I have 1 times 14 and 2 times 7. Next, we'll look at the constant term, and we'll take the sign with the constant term. I have a negative 2, and I'm going to list the factors of negative 2. I can do 1 times negative 2 or negative 1 times a positive 2. I want to test these pairs to see what combination of pairs will go in my first position and last position of each set of parentheses. To do this, I'm going to create a chart. This chart will test the pairs of combinations. So in the chart, I have two sets of parentheses set up, and I'm going to choose the 1 and 14 to go in the first position of each parenthesis. So I'll have a 1x, or a single x, in the first set, and a 14x in the second set. Now the second set of factors will go in the second position of my parentheses. First, I'm going to choose the pair 1 and negative 2. So I'll put a plus 1 in the first parenthesis and a minus 2 in the second parenthesis. Now I need to check to see if this pair works. This is trial and error. In order to check, we're going to multiply the outer terms together, which is x times a negative 2. That gives me a negative 2x. And then we're going to multiply the inner terms together. 1 times 14x will give me a positive 14x. When I add negative 2x plus 14x, I get a positive 12x. If this set of parentheses is the correct set, then this term will equal the middle term in my original problem. But if we go back up to our original problem, I have a positive 3x in the middle term. So 12x does not equal 3x, so I know that that combination of pairs will not work. We're going to check another pair. I'll set up my two parentheses. Now I still want to test the 1 and 14, but instead of the 1 and negative 2, I'm going to choose the negative 1 and positive 2. So when I set this up, I have x minus 1 times 14x plus 2. And again, we'll multiply the outer terms together. That will give me a 2x. And the inner terms together. That gives me a negative 14x. 2x minus 14x is a negative 12x. Negative 12x does not equal the middle term of positive 3x, so that combination will not work. Now I'm going to go to my second combination of factors for the 14. And I'll set up two parentheses. In the first term, I'll have 2x and also a 7x. Now I'll go down to the factors of 2 to choose my pair for the second position, and I'm going to choose the 1 and the negative 2. So I have a positive 1 and a negative 2. Next, we'll multiply our outer terms together, which is a negative 4x, and our inner terms together, which is a positive 7x. A negative 4x plus 7x gives me a positive 3x. That does equal the term in the middle of my original equation, so I know that those two sets of parentheses are my winning combination. Now that I know what two factors when multiplied together will give me the original equation, I can write these factors equal to 0. I have 2x plus 1 equals 0 and 7x minus 2 equals 0. I'm going to solve each equation by isolating the x variable. In the first equation, I'll subtract 1 on both sides, so I have 2x equals negative 1. Then I'll divide both sides by 2, and I'm left with x equals negative 1 over 2. With my second equation, I'll add 2 to both sides, and I'm left with 7x equals positive 2. Lastly, we'll divide both sides by 7, and we have x equals 2 sevenths. My solutions are x equals negative 1/2 and x equals 2 sevenths.